Okay, so today we're going to look at how single replacement reactions occur. Sometimes we can tell if a single replacement reaction will occur spontaneously even before it happens. Like we put two things together and I can say, I know this is going to spontaneously occur. So for example, and I'm going to try to find this stuff in the prep room. I don't know the prep room very well, but I'm going to try to find this to do this experiment for you. So if we have copper and we have some silver nitrate that's dissolved, that's AQ means it's dissolved, then copper will actually replace the silver in the silver nitrate. It will kick it out and it will become copper nitrate dissolved in water, and when copper nitrate's dissolved in water, it is blue. And so you can see that reaction happening right here. And also on the surface of the copper, you can see that there's like a sparkly substance on the copper that was put in there, and that is silver, pure silver. All right, so how do we know that copper would kick silver out of the compound and make a compound for itself with the nitrate ion? That is the question, and it's actually a very simple answer. All right, so how do we know this will occur before we put the copper in the silver nitrate? I know it will happen. It turns out there's a reference table for this. So if we look at table J on your reference tables, and we look at the metals in table J, we will see that copper, right here, is higher than silver, which is right there. And because copper is higher, it's going to kick it out. All right? You can think of, sometimes they make the analogy that the nitrate ion is with a partner with silver, but that copper looks better. And so that when copper comes along, they want to have copper as their partner and they kick silver out. All right. So, using table J, will the following single replacement reaction actually occur? Will magnesium react with this HCl? And will magnesium kick H out of HCl? So take a look at table J right now and see if you can figure that out. Does everyone have their reference tables? Should have your reference table. If you don't, I have some extra ones. Anyone need a reference table? So you'll notice on table J, H is not a metal, but it's on the metal side. It's kind of strange. And it also says H2, so that's just H. If H is in there, then it's H. You look at the H2. So how does the H2 relate in position to Mg? Is Mg hotter than H2? Will it take the place of H? All right, is it a yes or a no? Hunter, what do you think? Think it will? Okay, so let's take a look and see where Mg is on this table. So if we look at Mg, we see it's right there, and it's higher than H2, and it will kick it out. So yes, this does occur. Okay, let's look at another example. Will copper kick lead out of lead nitrate? We need to know what lead is. Lead is kind of a strange symbol. It's Pb. So if we look at that, you can see that Pb is higher than copper, and so it will continue to stay with the nitrate, and this reaction does not occur. Now, I'd like to say a couple things here on this slide. When we look at those previous examples, what's really happening when we have Ag copper nitrate in solution, when it's in a solution, what we're really saying is that, this is aqueous, what we're really saying is that it's Ag plus ions and NO3 negative ions. They actually come apart. If you recall from another virtual lab we did, when ionic compounds go into water and they dissolve, they split up their ions, okay? So we put some copper in there, okay? And what's really going to happen is the copper is going to change. We're going to take some electrons from copper, and we're going to put them over onto the silver. It actually takes 2 silver ions for this to happen. An electron goes over to here, and it goes over to there. And what happens is the silver now becomes just silver. Because, right, if we have a negative object and a positive object come together, it becomes neutral, right? What does the charge become on the copper? Now, it's lost 2 electrons, so what's the charge on the copper? Copper 2 plus, yep. So, that copper 2 plus and these 2 negative ions come together to make a compound now, which is copper nitrate. All right, so electrons were transferred over. So it's really an ion that's the metal is reacting with. It's reacting with an ion. All right, that's the detailed chemistry of it. It sounds a little complicated, and in some ways it is, but in other ways it's just changing electrons, and so it's not too terribly crazy. But you will find questions that say, which of the metals will react with an ion? And they'll just give you the ion. So you should realize that the higher on table J, the more likely it will become an ion. All right, and it will replace other ions. All right, there's one final thing. You will notice on table J, let me pull it up here. Okay, on table J, there's this one section over here that are nonmetals. Okay, so how does that work? Of course, I wrote it in the wrong spot. MgCl2, and I add to that some F2. Notice that the F2 is higher than the Cl2, and that single replacement will happen, and you'll get MgF2 and then Cl2, like this. All right, so realize that that can occur as well. Are there any questions on this? Okay, I'm going to post a Google form, and it will test you on this stuff and also review the stuff we've done in the last couple days. All right.